Hey everyone, I'm Don, and this is Jose. Today we're going to talk to you about building adaptive UIs, specifically for mobile and large screen form factors. So generally, when you think about building an adaptive UI, you think about how it looks on different form factors. You start with phones, which is still definitely the most important form factor, but then you consider tablets, foldables, laptops, desktops, TV, cars, and a whole bunch of other form factors. Form factors represent an abstraction for a device's size and capabilities. And they give us a shared vocabulary that makes it easy to discuss how our apps should look on a given class of devices. After all, we all know what a tablet is, right? OK, so let's test that. Hands up if you think this is a tablet. OK. About 75, 80%. So we're mostly in agreement there. OK, so same question. How about this? Do you think this is a tablet? This is like the same device in a charging dock with a keyboard and mouse. So, OK, so I'd say that was about 50% of you. So last one. How about this? Do you think this is a tablet? OK, maybe 20%? OK, so it turns out we don't all agree on what a tablet is. This is kind of fun, though, so let's do another one. Is this a phone? OK, so it's definitely a phone when it's not plugged into that monitor, but does it become something else when it's connected? So my point here is that we don't all agree on what form factors are. Devices can have multiple form factors. They can switch between them instantly, and they sometimes don't neatly fall into a form factor category. And this means that form factors aren't quite as useful as we once thought they were for designing UIs. Also, creating form factor-specific UIs can lead to branches or entire code bases with lots of repeated code and loads of maintenance requirements. So a better approach is to design and develop for UI capabilities, such as window size and pointer type. And this allows you to create an optimal UI regardless of the form factor. And with the APIs and tools that we're going to show you today, it doesn't have to be a costly investment, and you never know, it might actually be fun.
All right, so in this talk, Don will focus on the adaptive APIs, and I'll show you how you can implement the changes using AI agents. The good news is that AI agents make this a lot easier and a lot faster. You can adapt layouts, create regression tests, refactor code, and migrate to modern APIs. And in this session, we'll talk a lot about new APIs. The problem is that models might not know about them yet. And that's why we need to complement large language models with fresh knowledge. If we do this, then the accuracy improves a lot. For that, we've released 2 key resources that you should know and use as Android developers. First, the knowledge base, which is a collection of thousands of up-to-date articles, mainly from Android's documentation, but also Firebase, Google Play, Kotlin, Google developers, etc. And also, we released the official Android skills. Skills are modular instructions to help LLMs understand best practices and execute specific workflows. They are a lot more opinionated than regular documentation, as they contain specific instructions for agents. The knowledge base and skills are available in both Android Studio and the Android CLI, so you can use them from any agent. If you don't know what the Android CLI is, it's a collection of tools for agents that let you manage your SDK and emulators, deploy apps, and also it lets you search the knowledge base and install skills. Today, we are announcing an adaptive skill. It's an opinionated guide to help you make your UIs adaptive. You can download it from GitHub or using Android CLI. So now, with all of these resources, can you adapt a whole app in just one prompt, can you just ask the agent, make my app adaptive? It depends a lot on the app, but one thing is clear, the change is a lot better and in the long run faster if we go step by step and we have a clear plan.
Yeah, that's right. So the more you know about the tools and APIs, the better your prompts, the better your plans, and the better your code reviews. Plus, agents can make mistakes, so you need to be able to review any generated code. So in this talk, we'll give you the guidance and API information you need to get high-quality code from your AI agent.
All right, let's switch to the laptop. Done. There you go. So for this talk, we're going to be using this app that I vibe coded. It's called Paparazzi. It shows pictures of pets. It also has a messages tab to talk to other users.
Yeah, it wouldn't be Google I/O without someone showing you a new chat app, right?
Exactly. And it has a pet of the month with a simple list for now.
Yeah, and just to be clear, we know that all pets are the best. It's just a demo app, so.
Exactly. So this app looks fine. It's just a sample app made quickly with a simple UI architecture. But let's unfold first. You are probably seeing some issues already. By the way, I cannot recommend the foldable emulator enough. It's super handy to be able to rotate and unfold, to check multiple screen sizes with just one emulator. But let's see what happens if I rotate it. It's not great. However, this is the reality of lots of apps. And now that the portrait restrictions are being lifted, we really should focus on making this better. In case you don't know, in Android 16, you can't restrict your app to portrait anymore. All right, let me open the agent here and send a prompt just to show you how skills are activated. So I'll just say, make my app adaptive for now. So it's important to know that I previously installed the adaptive skill that you can see here. And immediately, the agent, or the model in this case, has decided to activate it. You can see it here. So if I open it, it's over here. We're not going to show the agent running the whole task. That's like watching paint dry. But all the prompts that we're showing in this talk have been run multiple times in an automated way, making sure that they always yield the same result. And they've been run with Gemini 3 Flash in Android Studio. All right, let's switch to the slides again. Cool. So even though we don't recommend this in a real app, let's just try this prompt with our sample app. Make my app adaptive. Once finished, the mobile version looks the same as it already looked fine. On a foldable, it now looks a little better. We have a navigation rail instead of a bottom navigation bar. And it even created a list detail layout for the Messages tab. In a bigger window, it's making better use of the available space.
Yeah, I mean, it looks pretty good, right? And all this in just a single prompt. Are we done?
Yeah, let's go home. No, this is the classic vibe coding illusion. Doing things from scratch or to a simple app like this one is a lot easier for models because they can just make generic decisions. However, more complex apps have more screens, different layouts, more customization, and there's just some decisions that you or your UX team should be making. For example, if we open the app on mobile in landscape, we see that there's very little space for the pictures. So the skill definitely helps, but if you ask the agent to make your app adaptive, but it's much better if you use it to support you along the way, going step by step.
OK, so instead of using a single prompt and hoping that the AI agent kind of does the right thing, we need a plan. And in fact, you can use the adaptive skill with your agent to create this plan. So the first thing we need to do is make sure our code base is ready for adaptation. And this means migrating all views to Compose. We announced that Android is now Compose first, meaning that going forward, all UI development should be done in Compose, and the view system libraries are entering maintenance mode. Plus, virtually all the APIs you'll see today are Compose, so basically use Compose. Next, you should you should migrate to Navigation 3. And Nav3's superpower is that it natively supports multi-pane layouts without changing the backstack state, which makes it perfect for adaptive layouts. Next, if you don't already have them, add tests to verify how your app looks on different form factors. These allow you to easily verify any UI changes. And you'll probably also need some behavior tests to make sure that nothing breaks when you're going through this process. So with that out of the way, you're then ready to start making your app adaptive. And for this, it helps to understand the process. So you use UI capabilities to drive decisions about your UI. And UI capabilities include things like window size and pointer types like mouse, touch, and stylus. And it also includes things like the type of keyboard being used and many other capabilities. And these capabilities can be used to change your UI at different levels. So at the app level, you could change your overall layout to display a bottom nav bar on a compact window width and a nav rail on wider screen devices. You can also adapt your main content layouts from single pane to multi-pane. And lastly, you can make lower-level UI components adaptive, like lists, grids, and buttons. For example, by making a grid of photos or cards with an adaptive number of columns. Now, these aren't hard boundaries. You can and should adapt your app at any level that is appropriate. So, all right, we've got a plan. Let's get to work. If you're still using views, migrate your screens to Compose. And you can wrap views inside Compose components if you don't want to do a full migration, but you should still consider it because, as mentioned in the last talk, we've got a skill for migrating views to Compose. And this skill can also help you create a plan, set up dependencies, deal with theming, and migrate layouts. And the models are actually really good at doing this. So using this skill can save you an awful lot of time. So once you've migrated your screens to Compose, we can get started with the Nav3 migration. And guess what? We've got a skill for that as well. The Nav3 skill contains a migration guide that converts Nav2 apps to Nav3. It includes a whole bunch of code recipes, including multiple backstacks, conditional navigation, and dependency injection. So it's a super useful skill to install if you're using Nav3. All right, that's all our migrations done. And the next stage would be testing. So,
all right, glad you asked. So any big change, any change really, needs a solid testing strategy. It's important to make sure that we don't break anything that already worked. And while we're at it, we'll add tests to make sure that the new features work across all the form factors. So first, we're going to make sure that we have a good testing strategy. And guess what? We have a skill for that. The testing setup skill is an opinionated way to add multiple types of tests to your app, and it's a great way to get started. You can use it to add tests in general if you have no testing strategy at all. It has good defaults that we recommend. But given that we're making a lot of UI changes, we're going to focus on enabling screenshot testing. Of course, you should also have UI behavior tests, unit tests, etc. In our sample app, we are using Compose Preview screenshot testing, which is handy because you can compare multiple window sizes very quickly with just one annotation. These are the specs that we're using: phone, phone in landscape, foldable, and desktop. But of course, you can customize that. Creating preview tests is extremely easy. You can right-click on a composable in Android Studio to generate its preview with the agent, and it will handle all the mock data, etc. So if you don't have them already, add screenshot tests before making any changes. That way, you'll track the progress, and also you'll be able to find problems in the future across all of your form factors. OK, great. So that's all our prep work done.
OK, cool. So now we can actually get to the fun part of actually making our app adaptive, starting with adaptive layouts. So I first wanted to share how we're thinking about you, the developer. And believe it or not, we do spend a lot of time thinking about you and what you need from our APIs. So we know that some of you just want a ready-made, out-of-the-box solution that works with your existing code base. Some of you want a good starting point for customization and extension. And some of you just want to build something from scratch. And our intention is to provide APIs and guidance for all of these approaches. And we know we might not have complete coverage right now, but this is just to let you know kind of how we're thinking in future. So let's talk specifically about the APIs that we have for adaptive navigation areas. So for an out-of-the-box solution, you can use the Material Navigation Suite scaffold. To customize or build app-level layouts from scratch, you can use Nav3's new Scene Decorators feature. And these allow you to wrap your main content with other content like nav rails and bars. So to customize an existing decorator, we have a recipe on the Nav3 recipes repository. And you can build your own by implementing the Scene Decorator strategy interface. And we have a whole load of fresh documentation on this.
All right, so we can finally start making changes to our app. Let's try this prompt. Make the navigation area adaptive. The skill contains a section about navigation suite scaffold, which is what you should use when you don't need customization. And this is the result from the prompt. The bottom navigation bar is replaced by a nav rail in a larger screen. And now that you are familiar with the APIs involved, you can check that they're being used correctly.
OK, so moving on. On larger screens, you can display related content side by side in multi-pane layouts, which can be a lot more convenient for users than going back and forth between screens. So there are two canonical multi-pane layouts. There's list detail, where the list and detail screens are shown side by side when the window width is large enough. And there's also supporting pane, where supporting content is shown to the side or underneath the primary content when you have enough space, and in a bottom sheet when there's not as much space. So both these are supported in Nav3 through the use of scenes. You can use material scenes for an out-of-the-box solution. You can use the recipes from our recipes repository as a starting point for customization. And lastly, you can implement the scene strategy interface to build something from scratch. And there's a dedicated Nav3 talk with Ben and Clara, released yesterday that covers all the latest features of Nav3, including the much-requested deep links feature, which it was released yesterday. So I know a lot of you have been waiting for that.
OK, so let's use the agent to do this for us, since we know that we have some list detail relationships in our app. The first one could be the pictures feed. However, I don't think that a list detail layout makes sense here. In a large screen, you want to use the screen real estate to browse through more photos at the same time. And when you select a photo, you probably want to see it as big as possible. But that's a product decision. It depends 100% on the use case. Maybe you want this. That's fine. So let's be explicit about what we want and go step by step. Let's convert the messages screen to a list detail layout. Also, it's better to be specific in the prompt rather than leaving it up to the AI. So you might want to decide now if you want to show maybe the first conversation, or instead a placeholder when no conversation is selected yet. Let's go with a placeholder that says select a conversation. And this is the generated code. The list detail scene strategy contains a detail placeholder, so the model uses it thanks to the skill. And here's the result working as expected. But that's not all. Again, to save time, after big changes, I like to ask the agent to build, generate screenshot tests, or even deploy the app to the emulator, navigate, etc. But wait, does your agent have the skills to manage emulators? Well, obviously, we've got a skill for that. The Android CLI has an emulator manager, and with the skill, you can say things like deploy to the emulator, and the model just knows how to do it. If you want to know more about Android CLI, check out the developer tools talk.
OK, so that's our app layouts been made to be adaptive, which is great. So let's now look at how we can make individual UI components adaptive. So first, anywhere that you're using a list or a grid with a fixed number of columns or rows, you should consider using an adaptive column count. And you can use any of the lazy grid layouts for this. Then, when specifying the column count, you can use grid cells adaptive. And this takes the minimum column width and creates as many columns as it can in the available space, and any remaining space is distributed equally throughout each column. So our feed screen is actually a prime candidate for this. It currently always shows 2 pictures per row, which is fine on mobile portrait, but on a foldable, as you can see, it doesn't really scale very well.
All right, so this is something covered by the skill. We have a section on making lazy lists adaptive. So what prompt do I use to do this? Make this layout adaptive? Yeah, this might work, but it would be much better if you are specific about what you want. So show 2 columns on portrait phone, 3 on a foldable, 4 or more on bigger screens. However, you don't have to tell it to use the grid cells API, but it's important to know what's possible so you know that a prompt like this will work first time. The model is smart enough to calculate that a minimum size of 180 dps is what we need to match those constraints. And this is much better now. Now it adapts to the size, showing a different number of columns depending on the space.
Yeah, definitely much better. But if you rotate that phone to landscape, you can hardly see that first row of images. In this case, we should hide that bottom nav bar when the user scrolls to make more space for the content.
All right, let's just do it. Make the bottom bar collapse on scroll when the height is compact. This is a very common pattern, so let's see if a model is capable of it. And now it's looking better, but what happened here? There's too much padding at the top. We're drawing behind the camera, and the bottom navigation went transparent for some reason. It's almost as if the model didn't have the skills to go edge to edge, which with the new APIs. And you're not going to believe this, but there's an edge to edge skill. Combining this one and the adaptive skill, you'll be able to implement collapsible top and bottom bars. And of course, it includes all the basics of edge to edge, including troubleshooting and what not to do. So let's install the skill and go edge to edge. Make lists go edge to edge, collapse top up bar and scroll, and show it again when the user scrolls all the way up. That's important because there's 2 modes. When the height is compact and the user scrolls, collapse the navigation bar. I like to include multiple tasks in one prompt when they are related. That actually saves time and tokens because the agent doesn't have to figure the context twice. But you can split it in 2 if you want. So with this information, the model can come up with the relatively complex compose code needed to make all of this work. And of course, it did the right thing. And now a user in landscape can see 2 full rows of pictures using all the screen space. There's no custom landscape layout, just some code to make the same layout adapt to different configurations. So let's continue.
OK, so in that last prompt, we introduced the concept of using a UI capability, the window height, to make a UI decision, collapse the bottom navigation bar. And this is a very common pattern, and it's used under the hood by the adaptive layout APIs we saw earlier. For example, the material list detail scene strategy uses window size to determine when there's enough space to create a list detail scene. But what if you want to get access to those capabilities yourself, so you're in charge of making those UI decisions? Well, here's how you can do that. So the most important property that you'll want to get access to is window size. And you can access it directly using local window info. But it's often more convenient to work with window size classes. These are opinionated viewport breakpoints that help you design app-level layouts for typical scenarios. You can use materials predefined window size classes, or you can define your own using window size class. So another important capability is how the user is pointing to your UI elements. And this is important because a mouse pointer is much more precise than a finger. So when using a mouse, the target areas for UI elements can be smaller, and you can create a denser UI. Now, there's plenty more UI capabilities, including device posture for foldables and laptops, and whether a physical keyboard is attached. And the APIs for all of these capabilities have been around for a long time and are spread throughout the Android API surface. Many of them are pre-compose, which means sometimes they require kind of a bit of massaging to get them to work nicely with Compose. And this is why we are introducing a new experimental API called Media Query. Now, it's inspired by the CSS Media Query API. So if you're thinking, why is it media? Is that to do with like video or audio playback? Well, media refers to the type of device that the UI is being rendered on. So this API currently has capabilities for window size, pointer precision, whether the device has a microphone, camera, keyboard, and how far the user is viewing from the screen. So if you want to try it out, here's how to use it. So the media query function accepts a lambda where you can access these UI capabilities, like pointer precision, and it returns the same type as the lambda. So the media query function will recompose whenever one of the underlying UI capabilities accessed inside this lambda changes. So you can rely on media query to recompose any dependent composables. A convenient pattern here is to have your lambda return a Boolean. For example, in this code sample, we're returning true when the primary pointer has fine precision. And we can use this to make your UI elements smaller. So when a less precise pointer is being used, like a touchscreen, we can make our UI elements larger. Now, you'd usually do this by customizing the style for the UI element. And we actually have a new API to do this, the Style API. And if you want to know more about this, then stay in this room, because the talk after ours talks all about this. So anyway, back to Media Query. For rapidly changing values, like window size, and this can rapidly change when you're running your app on a desktop and the user's drag resizing that window, you would use derived media query. And this allows you to say, I'm aware that my state is dependent on a value that is rapidly changing, but I only want to recompose when the derived state changes. So Media Query is very much an experimental API. Please do try it out and file issues and let us know what you need from it.
All right, so even though it's experimental, the documentation for Media Query is available in the adaptive skill and the knowledge base. So if you ask the agent to use it, it will fetch the information. So let's try it out. Let's say to the agent, reduce the padding of pet filter chip to 2 dps when the pointer precision is fine. It uses the write media query construct that is only updated when necessary, and then we can just assign paddings. And this is the result. On a device with a mouse or a trackpad, such as a laptop, the filters will be a little bit smaller.
Cool. OK, so we have a couple more experimental layout APIs to share that can be extremely useful when you're creating adaptive UI. So first up is FlexBox. Now, FlexBox lays out items in one direction, and it can resize its children to fill the available space. You use the Flex modifier to access Flex's properties. And here we're using the grow property to have that central child grow when there's any extra space. And this is particularly useful in places like top hat bars when you want a single item to grow and everything else remains fixed. So FlexBox can also wrap items onto new rows when there's not enough space. And you use FlexBox's config parameter to configure container behavior, like wrapping here. And this is very useful when you have child items of differing size, and you can wrap them onto new lines. So this is really only scratching the surface of what FlexBox is capable of. So yeah, check it out and see how you can use it. OK, so let's continue making our UI components adaptive. Now, our designer wanted to show all the filters in the feed when there's enough space for it. So right now, we're showing a single scrollable row. So some of these filters are actually going off the screen. So extremely conveniently, this feels like a job for FlexBox.
No problem. Let's ask the agent. In the feed, the filters should be shown in a scrollable row, but from 600 dp's width, wrap them so that they are shown in multiple rows. Note that I'm using 600 dp's here instead of a window size because I'm talking about container size. And this is the result. Now the code is a little bit more complex, but it does exactly what we asked for. Depending on whether it's wide or not, we wrap or we apply a horizontal scroll. And this is the result. We have a FlexBox that wraps on large screens.
Nice. OK, so FlexBox is great for one-dimensional layouts, but for complex 2D layouts with items that span both rows and columns, we have another experimental API called Grid. And you configure it the same way as FlexBox with a config block for the container. And in this example here, we use the column and row functions to define a 3x3 grid with 100 dp cell sizes. And we can also specify the gap between the rows and columns. We use the grid item modifier to access grid's features, like spanning across multiple cells. So here we're using row span and column span to make that green box fit into 2 cells wide and 2 cells high. Now, grid is great for situations where important items need to be larger, but everything still needs to be aligned to the grid. And it just so happens we have the perfect feature for grid in our app, which is the top pet screen. Currently, it is showing all of the pets the same size, but what I think would be cool is if we have that very important first place pet take 4 times the amount of space as the other pets. OK, so this is like my vision. We can have a 2x4 grid on mobile portrait, and then on larger screen devices, we can switch to a 4x2 grid.
Beautiful.
We'll see.
All right. So again, we don't need to tell the model exactly how to use the API. We just need to describe what we want. So make the top pet screen adapt to different window sizes. It should always show pet number 1 using a 2x2 grid cell, while the rest take up 1x1. And the grid cell should be 2x4, 4x2, depending on the available space. So here's the code. Again, it's a couple of very easy to understand if statements, and then we just calculate the cell size. And here it is. It correctly interpreted what I meant with available space. So we're done here.
Yeah, I mean, it looks all right. So this is my idea, and I'm not a designer, I'm an engineer. So just try and imagine how good this would look in the hands of an actual competent designer. OK, so we're done. Hopefully, you can see the power of these new APIs, and that making your app adaptive doesn't have to be a load of work. So if you are interested in going from mobile portrait or wherever you are on your adaptive journey, this is where you should start. So all of the skills that we've mentioned will help you bring your app into kind of the adaptive world. So start with migrating screens to compose, and even if you have to wrap views, Then you can use the navigation 3 skill to migrate from nav 2 to nav 3. You also should add tests, and then you can start asking your agent to make your layouts adaptive, preferably one by one, and preferably with detailed prompts and even mocks produced by your UX or product teams. Lastly, definitely check out the repository for skills. We're adding new skills all the time, and we currently have skills for the Android Gradle plugin, performance, for camera, where, and a whole bunch of other very useful skills for Android development. And if you want to learn more about how to use these skills, you can check out the Develop with Android Studio talk, which was actually the talk before ours.
All right, so to end this talk, we'd like to say that it's absolutely awesome that a complete beginner can create a prototype app in 2 minutes. But what users really care about is quality. Apps that delight them. Apps that don't ask me to log in every time I use them when there's no reason, that work in dark mode, that support edge-to-edge, and of course, then I can use on multiple devices in any configuration. That's quality. I just want to be able to rotate my phone while I'm filling out a form without having to start over. That's also quality. And AI agents and LLMs can be incredibly helpful in producing high-quality apps, as long as you know what to ask for. So with AI, a good developer will create a good app, and an excellent developer will create an excellent app. That is not changing. So now it's the time to make your apps adaptive. We understand that you still need a little bit more QA, maintain a little bit more code, but the investment is considerably lower now, and the return keeps growing every day. So you're not going to get there in a single prompt, but it's so much better now. You might even have fun. Thank you.